Hello students, welcome to our fifth lesson on trigonometry. I hope you are all doing well. Good. Now before we begin our lesson, let's take note of the following announcement. After watching this video, if you realize that there was a concept that you didn't understand, please give me a call for further explanation and clarification. My number is on the flyer on your screen. So my number is 0245 507367. 0245 507367. So don't hesitate to give me a call. Okay? Good. Now you can also see on the flyer that I run some online courses. So if you are in need of these services, or if you know someone who is in need of these services, please call or give my number to the person for him or her to call for enrollment. And trust me, you will never regret. Right, that was just by the way. Now, before we begin our lesson, we talked about the fact that under trigonometry, we are going to focus on the relationship between the length of sides and angles of right-angled triangle. So we said that we will be precise, we'll focus on right-angled triangle. So we said that there are two relationships, that is the one between only the length of sides and the one between the length of sides and angles. So we started with the one between only the length of sides, and that was what we've been doing till now. Okay, so today we'll end on the relationship between the length of sides only. Then in our next lesson we'll begin the relationship between the length of sides and angles. Good, that is trigonometric ratio. So we'll end our lesson on the Pythagoras theorem today. So I told you that we'll be looking at Pythagorean triples or Pythagorean triplets. Right, so that is what we'll be doing in this lesson. Good, so we'll look at the definition of Pythagorean triplets, then we'll look at how to derive them, and then we generate some of them, and that will be all for the lesson today. Okay, good. So let's begin. What is Pythagorean triples or triplets? Okay, good. So Pythagorean triplets or triples is a set of three natural numbers that obeys the Pythagorean theorem or the Pythagoras theorem. So let me take it again. Pythagorean triples is a set of three natural numbers that obeys the Pythagoras theorem. So the underlining words are three natural numbers, and these three natural numbers should what? Obey what? The Pythagoras theorem. So a set of three natural numbers that obeys the Pythagoras theorem is referred to as what? Pythagorean triples or triplets. Right, good. So that is the definition. That is the definition. So if you have a right-angled triangle, okay, and we discussed this already. So if this is C, and this is capital C, this is B, and then this is A, so small a. We know from Pythagoras that C squared is equal to A squared plus what? B squared. So the numbers or the letters A, B, C, that is A, B, and C, if these numbers are natural numbers, then A, B, and C are referred to as Pythagorean triples. So if A, B, and C are natural numbers, then we refer to A, B, and C together as Pythagorean triples. Okay, good. So now that we know the definition, let's look at how to derive these numbers. How do we derive these numbers. Good. So how to derive Pythagorean triples? How to derive Pythagorean triples? So let's look at it. So we have for any two natural numbers m, n. So for any two natural numbers m and n, where m is greater than what? N. 2mn, m squared minus n squared, m squared plus n squared are said to be Pythagorean triples. So for any two natural numbers, so any two natural numbers m and n, where m is greater than n, so the m should be greater than what? Than the n. If this condition is satisfied, then 2mn, m squared minus n squared, m squared plus n squared are said to be Pythagorean triples. So basically, this is how we generate all the three triples. Okay, so you have to keep these formulas in mind. 2mn is one, m squared minus n squared is another one, and then m squared plus n squared is another one. Okay, so the m squared plus the n squared is always the hypotenuse. Okay, so this is always the what? The hypotenuse. Okay, the hypotenuse. So m squared plus n squared is always the what? The hypotenuse. Good. And then this two can be any of the other two sides. So students, this is how to derive the Pythagorean triples. This is how to derive the Pythagorean triples. Right. So the two numbers that you pick, they should be natural numbers. And the first one should be what? Bigger than what? The second one. The first one should be bigger than the second one. Good. There are other formulas, but this one seems pretty easy to remember. Okay, good. So now that we've looked at the definition, we know how to derive them from this formula. Okay, so we are learning the derivation by what? A formula. That is this, this, and this. Okay, so now that we've learned how to derive them, let's now generate the numbers. Let's look at how to generate these numbers, the triples. Right. Good. So we have a table here. We have a table here. So 2mn in one column, m squared minus n squared in another column, m squared plus n squared in another column. So we are to generate the triples. Okay. Good. As from the derivation, we said that the m and the n, they should be natural numbers. So what are natural numbers? They are basically what? Counting numbers. So they start from what? 1, 2, 3, and so on. Okay, good. So if you pick any two of these natural numbers and you substitute them into these formulas, you will be able to generate triples. That is Pythagorean triples. So let's take some numbers. So the simplest natural number is what? 1. So from 1 move on to 2. So let's pick 2 and 1. So 2 will be bigger than 1. So we have 2, 1. So the 2 is our m, the 1 is what? Our n. Now let's try and generate them. So we are going to have 2 times 2, which is 4. And then 4 times 1, which is also what? 4. So these 2 times the m times the n. Now the 2 and the 1 are the m and the n. So you take these 2, multiply by these 2, you get 4. You take the 4, multiply by the 1, you still get what? 4. So this is what? 4. Then you come here, the m is what? 2. So 2 squared is what? 4. So note it down. 2 squared is 4. 1 squared is what? 1. Okay. So 4 minus 1 will give us what? 3. So we have 3. Then the last one, we've seen that m squared is 4 and then n squared is 1. So 4 plus 1 is what? 5. Good. So this is our simplest Pythagorean triple. And this number 3, 4, 5, okay, this set of numbers, they are called the primitive triples. Okay, primitive triples. So these are the primitive, mean that from these ones others can be generated. They are the basic or earlier triples. Okay, so 3, 4, 5 is a primitive triple. So you can generate other triples by multiplying this 3, 4, 5 by factors. So when we multiply this one by 2, we'll get a different set of triples. So multiplying this one by 2, we'll get what? 6, 8, and what? 10. So this is also another triple. These numbers obeys the Pythagoras theorem. Good. So let's continue generating more of the triples. So now let's pick 3 and 1. So picking 3 and 1, 2 times 3 is what? 6. 6 times 1 is what? 6. So here we have 6. So 3 is the m. 3 squared is what? 9. 1 squared is what? 1. 9 minus 1 is what? 8. Okay? 3 squared is what? 9. 1 squared is what? 1. 9 plus 1 is what? 10. I hope you are following. Good. So let's pick 4 and 1. So our first number, we have to multiply the m and the n by 2. So 2 times 4 is 8. 8 times 1 is what? It's still 8. So we have our 8. 4 is the m. 4 squared is what? 16. 1 squared is what? 1. 16 minus 1, 15. Okay? Then 4 squared is what? 16. 1 squared is what? 1. 16 plus 1, 17. Good. So this is also another set of what? Triples. So now do this one for me. Quickly do this one for me and let me see. And then finally, good. So pause the video and then try your hands on this 3 for me. Okay, I know by now you are done. So let's see the solution. So now with 5 and 1, we are going to have 10 times 1, which is 10. So the first column will have 10. Then 5 squared is 25, 1 squared is 1, 25 minus 1, 24. Here we have 25 plus 1 is what? 26. Good. Then with the 6, we have 2, 6, 12, 12, 1, 12. So this place will also be 12. 6, 6 is what? 36. 36 minus 1 is what? 35. And then 36 plus 1 is what? 37. Good. The last one, 2, 3 is what? 6. Okay, so take note of this one. You realize that the number is no more 1, but what? 2. The n is now 2. So 2 times 3 is what? 6. 6 times 2 is what? 12. So you put 12 here. Okay, now 3. 3 squared is what? 9. 2 squared is what? 4. So 9 minus 4 is what? 5. Okay, then 9 plus 4 will give us what? 13. Okay, so students, there are more. You can generate a lot of them. by just picking two natural numbers, where the first one is greater than the second one. You will generate a lot. Okay, good. So you just have to be conversant with some of them. Okay, some of them. This one, this one, this one, they are common. Okay, so get yourself acquainted with some of the common ones. These are common ones, so make sure you know these ones off head. So anytime you have a right angle triangle with one side being 4 and one side being 3, automatically the hypotenuse will be what? 5. When one is 8, one is 6, one is 8, hypotenuse will be what? 10. When one is 8 and then one is 15, hypotenuse will be what? 17. Okay, good. So make sure you memorize some of these basic ones. If you don't know any triples at all, know these ones. Okay, but from what I've shown you, you can generate more and then add it to your knowledge. Right. So students, this is where we'll bring the class to an end. So we've looked at the definition, we've looked at the derivation, and then we have generated some of them. Okay, so get yourself acquainted with these simple triples and common ones. Okay, then you'll be good to go. Anytime you see a right angle triangle, you can easily identify the hypotenuse when the other two sides are given. Good. So till we meet again, revise, read ahead. Bye.